Hello folks. We are live and I'm going to pull back our music here a little bit. Alright, I see us. And Prana, could you do a quick sound check for me, please?
Hello, I'm here.
Okay, I hear you. Okay, so we should be good to go. Yeah, if anybody has a hard time following us, please let us know. Ooh, I see the green screen of death. But the good news is I think I know how to fix it nowadays. This was an issue a few weeks back, but it's just our video card needs a quick reboot. And that should fix it. All right. Oh, hang on. We have not had this issue in 2 weeks. Okay, let's try. Essentially, I'm trying to show my desktop and it's not liking it. So let's give it a complete reboot by unplugging wires and plugging them back in. And I'm going to check my settings here. Okay. Okay. I think we're back. Yeah. Alright, so we'll keep an eye out. If it goes off again, we will give it another kick and reboot it. Okay. Sorry about that, but folks, we are finally ready to get started. So good morning if you are in North or South America. Good afternoon, good evening, anywhere else in the world. And thank you for joining us here at Code It Live. As you know, this is a channel where we code about a bunch of different things throughout the week. You saw me do some CMS yesterday. We do a podcast. Today's Tuesday, so it's all about Unity and me learning. Wednesdays we have some React and some UI. Thursdays I do Xamarin and XAML technologies, and Fridays we end with a chat show. So yes, come and join us whenever you want. Oh, and in the chat room I see our good friend Ivana. Good to see you, Ivana. All right, so I'm Sam Basu. I'm a dev advocate at Progress Software, and with me I have my good friend Pana Atkanko. So Pana, please introduce yourself.
Hello, I'm Pana Atsankov and I'm a software developer at Progress Software.
Good to have you. And Pana is actually in Sofia, Bulgaria. I'm going to make your head a little bigger. You look small. You look a little
Thank
small.
you.
There you go. A little bigger head. All right. Yeah. How's life? How are things in Bulgaria?
It's good. It's good.
Yeah.
We're working from home
Yeah,
for the
we
last
all are.
few months.
Yes. Well, I mean,
We're
we
trying
are.
to get used to it. Yeah.
Yeah, we all have. I mean, we are living through a global pandemic, so It's fun, and it's different in different parts of the world, like how much the impact is, and yeah, let's all try to be safe and be productive and positive. So let's begin. Pana and me do this every Tuesday, where we just open up Unity from scratch. I have never done Unity, so it's a big learning experience for me. Pana has been doing it for years, so I'm essentially trying to learn. And Pana could not join me last week. We had a friend of ours join me and help me on chat. So I did a few things that I want to run by Pana because I have a lot of questions. So if you are new to Unity, just like me, folks, start on unity.com. And I found some really good API docs. This is their documentation portal for all things, right? So you see scripting, you see graphics, audio, video, animations, UI, I mean, everything. I mean, it's decent. There are some things where I feel like I could use more explanation, but for the most part, it is good. And scripting is what we're talking about. This is where we are manipulating game objects with C# code, and that's what we want to do. So we're going to dive into scripting and all of the different things we can do today where we left off. Let me see, I think I found a few more things about beginners that I wanted to ask you. Hang on, variables, functions. Okay, so let's stop there, and I'm going to pull up a project that we've been working on. So this is Unity Hub, folks. This is where we have been building up projects here. This is the card game. This is kind of one of those default tutorials that you find from Unity, and this one is actually fairly good. You get 4. There's a first-person shooter. There's a cart. There is I'm drawing a blank. There are like 2 others, and all of them kind of get you used to Unity because it is a busy IDE, and kind of how to move around, how to change things, and it's a pre-built game, so you can have some fun. Then this is the project that we are starting on, learning physics, because I want to dig into a little bit about like how the physics of particles and all of these game objects work. So that's the project we have been working on. So it takes a minute to come up. Unity editor, new edition. Yep, nope, don't want to do that right now. All right, go away. Okay, here we have Unity. Before we start the Pana, I have a few questions on what we did. And let me pull up Visual Studio here, because we've been writing the Visual Studio code in, or the C# code in Visual Studio. And it's this one here. So if you are new to this, like I was, there is a setting in, oh, and even Visual Studio has an update. So thank you, don't want to update right now. There is a setting in Unity, actually, not in Unity Hub, but in Unity. If I go in here, see that external tools thing, you want to set that external script editor to be in Visual Studio. And you definitely want to regenerate the project files, because this is what gives you the solution files and the CSproj files. So then Unity knows, or Visual Studio knows exactly what type of project it is, and IntelliSense lights up and life is good. And you can do this in Visual Studio Code on Windows or Mac, doesn't matter. So that's where we are at. And Pana, I want to ask you a couple of things here. So when we first start up scripting, like this is different. This is not just like a program execution where we have to bootstrap the whole application. This is just Unity engine running continuously and giving you a couple of hooks on where to write your code, right?
Yes.
Okay. And I see like there are, like when you start up a script, they essentially give you the start, which is when your game object is active and it is enabled and it's working, and they give you update, which is called once per frame. So as we paint each frame, Unity comes in and says, what do I have to change? And it does its thing. But looks like there are a few other kind of entry points or a few other hooks we could use. Like there's an awake. It's when the game object is first like instantiated. So do you know about these things, these other ones, Pana, like the fixed update and the late update?
Yeah, I can give a little bit more of information. So awake and start look very similar, but This is the thing. When you compose your game objects, Unity serializes them into the scene, and when the game starts, Unity will actually run a code to deserialize the game objects. And the deserialization is something that is available in C# and .NET as well. Usually doesn't run constructors, and it's a bit of magic. Once the objects are created, the awake is the first method that you can actually add your own code. But here is the deal. There isn't something like dependency injection in Unity. So if you have multiple scripts that depend on one another, usually you use awake just to set up your object to create instances that you depend on, or look them in the game object hierarchy, but you do not interact with them because their awake method is not yet code. And later on start, if you want to bootstrap something or to kickstart other objects, you actually can do this in start. Then there is update and fix update.
So before you go on to the updates, quick question.
Yeah.
On the awake, is the awake called only once when the game object is initialized, and beyond that, if the game it's always the start, right?
They're both called once.
They're both okay.
Yeah.
Okay.
But there is difference in which one. I mean, the awake will be called on your script even if the game object is inactive, which means that if I have something like a script that is a manager and interacts with a few other scripts, even if they are disabled, I will need them to prepare themselves enough so I can enable them later. And that's why awake is called even if the game object is inactive. But the start is called only when the game object is enabled. Yeah, okay. So if you have like enemies, you can create several game objects that are disabled initially. Their awake method will be called.
I see.
And yeah.
I see. So like you can keep them disabled and then turn them back on as your game needs. Okay. And update is pretty obvious. It's something you want to do every frame. But then fixed update is when you want to do physics work. What's the difference?
On a desktop platform, you will try to run with high frame rate, but if you have complicated graphics or C# scripts, you can actually delay the rendering and drop the frame rate. Wow. So the update is called once per frame. Yeah. And on the other hand, even if the frame rate is low, I mean, if the game is not running at 60 frames per second, but at 30 frames per second, you will still want the physics to look realistic. You will not want to have the objects start falling slowly just because you're dropping frames. So Unity has this fixed update. So this is the main difference. The time between two update calls varies, but when fixed update is called, the time that will be provided to the fixed update will be in equal intervals, so the physics can look the same. You can have several fixed update calls between one update in a single frame. So yeah, that's the difference.
Okay. And late update makes sense based on the documentation. It's like the last thing you want to do before you come out of update. Really helpful for moving the camera and focusing on it so it doesn't look jittery as your game object is moving around. Okay.
Yes, especially. Yeah.
No, go on. What were you saying?
Basically, the update is called.
No, go on. I'm hearing.
Okay, so the update is called on all game objects early in the frame when they want to prepare to render, but if you have something like input, for example, in VR, if you want to drag an object and you're using your hands or a mouse, you can actually take that input in late update. So it's in the last possible moment before you react. Yeah.
Okay, so both update and late update are called. This is late update is the last thing you do.
Yes.
Okay. All right. Yes. So let's dive into some code, and I have some questions as to how things are working. So going back to Unity, this is a pretty simple thing that I have. So it's just a plane, and I have a sphere. And we were able to give the sphere a little bit of color, and we are trying to play with physics and the rigid body and how to move things around, and also like the frames actually come into play. So Pana, this is what we did last week. So I was actually glad to see, like, if you add properties to your game object, those show up in Unity right away, and those are properties you can edit in Unity. Yes. Which is very nice. And then, so you'll notice that on the start, I'm getting the rigid body for that particular game object. I'm giving it some mass. Now, what's with this floating point? Like in Unity, why do I always have to keep on saying like F? Is it not obvious to Unity that everything is a floating point?
This is a C# thing, actually.
It's a C# thing.
The .NET uses doubles everywhere, but Unity has to run well on consoles, for example, where you would prefer to use floats instead of doubles for performance reasons. And even if you try to pass things to the video card, the float is more frequently used format.
Okay.
Okay,
good to know. So, no, go on. What are we saying?
What I mean is the compiler will figure this out mostly. So even if you use the 10 constant without the F, when it compiles the code, it will figure it out. There are very few places where you have to specify the F.
Okay, good to know. Because I mean, coming from just like doing regular C# for like desktop and web stuff, like we're not used to writing F all the time, but I can see why. Okay, so here's what we did. So we gave the sphere a little bit of a mass, right? And then on key down, if I hit the space key, we were playing around with a few things. Like I can obviously destroy it, but then it's gone. We can also disable it, which we learned. But here I'm adding some force. So I'm adding some vector force, and I'm saying go up. And the force mode impulse is kind of like giving it a push. Right? If I say tab, then it can come back. It's not doing anything right now. But if I do a comma, so let me show you. Maybe before we go into the comma, let me show you what this looks like. If I go into Unity and if I go into play mode, I see a few follows going around. Thank you, folks, in the chat room. Thank you. So if I hit my spacebar, this thing jumps up a little bit, and then watch how, like, if I keep hitting the spacebar, then it's calling update like every frame, and this thing just keeps on going, and then it has gravity, so it falls, obviously, right? So I'm just literally giving it a force upwards by like 20 every time we do that. So I mean, for anybody who's experienced, like, this is so easy and obvious, but I'm not. I'm learning, and this is pretty fun for me to be able to do these things. So the next thing I was doing, and this is where I have a couple of questions for you, Pana. So if I hit a comma, I mean, I could get any other key combination, but what I'm doing here is what's called a coroutine, and I'll pull up the docs here so everyone can see. So the problem with calling loops while you're in update, like, the update has to be quick, right? I mean, does Unity have any recommendations on like how fast your update, like whatever you're trying to do in your update loop, like how fast it has to run? Is there a limitation?
No, there isn't a limitation, but if you execute a lot of code in your update methods, you will slow the frame rate.
Yeah.
Because
Obviously.
the update is supposed to prepare your frame. Yeah.
Right. Okay. So I was learning, this coroutine thing I was learning, and it seems like what you were saying, like you don't want to slow down your FPS, but you want to do something over a few frames. So this one is what I have here. So when I hit the comma, we are going to call this thing called fade, and this fade is of the type IEnumerator. I don't know why, because that's kind of how Unity likes it. And then it gets the renderer, which is the mesh, and then that sphere which we had was a color red or whatever. We take the color, and the A is the alpha component of it, and we just slowly bring it from red down to like transparent. And this yield is essentially saying like you do until this on one loop, and then you yield control back to Unity, and then you come back on the next update, on the next frame, and you start this loop exactly where you left off. Am I saying that right?
Yes, absolutely.
Okay. So before we do this, like on every game, like is there an FPS setting that you can control on like your game based on like its desktop, its mobile, its VR?
Yeah, there are APIs to control the FPS, and also there are settings in Unity. If you go to the project settings, you can see various quality levels, things like anti-aliasing.
Project settings. Where are the project settings? In Unity, is there a project level? Like
it should be. Yeah, but I think it's in the file menu. File.
Yeah, it has new scene, open scene, build settings, build and run, and then it has game object settings, component settings, assets. Again, I mean, it's not important. Maybe you can show me some of the time. But like, what's the default? Is it like 60 FPS? What's the default for Unity?
Yeah, for the desktop, I think it's about 60 FPS. For mobile, it's about 30. To be honest, I'm not used to the Mac. Oh, here it is in the edit project settings.
Oh, I see. Yeah, you're right.
Menu at the bottom.
Okay, so I have input manager. I have physics.
Yeah, so you can configure like the things like the gravity, the step for the fix update. Also I think in the quality somewhere there was a FPS cap. There is also an API to control the frame rate limit.
Okay, good to know. Okay. But I mean, we're not messing with anything. We're just going with what it is. So what this wait for seconds does is essentially like once it comes back in the in the update on the next frame, it like waits for like 0.1 second before it executes that. So let me show you how this is looking, at least for me. So we had to give transparency to the mesh, and then when I hit a comma, you see that it slowly becomes transparent, and it's not like an immediate transparency because we are calling the update over several frames, right? And so is this working the way you expect it to work, like when you use coroutines like this?
It works well enough. I would change one little thing. When you return wait for seconds, you can actually run a few frames with the same color.
Oh, okay.
Or you can run, you can change the color several times in a frame. So I think you can return null. It is even more special than the wait for a second. And
so if I just do return null,
it will.
Okay.
Yeah.
All right.
And then it will execute with the update method slightly after the update, but it will execute once per frame.
Okay. So will it slow down or will it fast up the color change? Like this actually make
will not
fast up,
we
right?
will not notice it.
Okay, let's try it.
Yeah.
So I'm here, I'm hitting the comma. Oh, wait.
So yeah, there.
I was not in game mode.
I want
One
to
second.
send you a link.
Yeah. Yeah, I think this is happening actually quicker if I do that.
Yeah, probably. Maybe it's running several frames in a. I mean, when you wait for a second 0.1, it runs 10 times in a second. Now it runs as much frames you have in a second, so maybe it runs 60 times in a second.
I see. So that's why it's faster. So if I make this bigger, does that make it bigger? Like, I mean, could I just make it weight 1F?
Here,
what will that do? If I just make it wait 1 second?
It will change the color once per second, which means that you will probably run 60 seconds with the same setting, and then it will change a little. It will appear to be animated more slowly.
I see.
But when you're running animations, when you're making animations, there you will probably want to update the color once per frame. So there is something else that we can use here. There is a time class, and the time class has several static constants that you can use here.
Okay.
Yeah, so that's it. Basically, you can use the term null and then check the time, and it will tell you like how much time has passed since the last update, and adjust the color based on time and not iterations.
Okay.
Okay.
So let me try what changing that one thing does. See if I hit that. Now it's just like it's switching, like it's not as smooth. So I see what you're saying. Like when you're doing it, you're saying it like do it 10 times a second. That's a little smoother animation, at least. But I thought this was interesting. Like I mean, this is just like a stupid example of just changing a color, but this actually brings up a quick question. So, and I know Unity has documentation on this. So the reason why Unity is able to come back to a certain for loop in between multiple method calls, like multiple update calls. So like the garbage collection, like that does not kick in, right? Every frame, obviously. How long is it maintained? Do you know?
This loop will be maintained until it completes. This is what happens. You basically call start coroutine fade, and the Unity will check the fade method and will see that it makes a numerator, so it will run the method and capture the numerator. It will try to iterate all values that the numerator generates, but once it gets a result, it will check what is the result and will decide when to progress the numerator to the next value. So this happens behind the scene, but it's not that strange. And Unity will actually hold the numerator for you. Yeah.
Okay.
You can stop the coroutine if you wanted to go away.
Okay. Yeah, I found a full article on automatic garbage collection and memory management on what it's doing. So this will be a bit of a read for me, trying to understand. You can disable some garbage collection, looks like, and it's all coming from the same heap that Unity is giving you, like a placeholder to take some memory and do stuff. And I think they will just wait, yes, like you were saying, for that loop to finish before they collect the garbage. Okay. All right, so this is good. Now the other thing I want to try a little bit more is some physics, some velocity, some collisions. So let's try that. I think I saw something where let's see. Those are the transforms, right? Like, or how do I give it like velocity so I can move forward and I can hit something else? Those are all rigid body.
You still have to, add the rigid body.
Yeah. Okay. So what if I wanted to do this? What if I wanted, like, I have a sphere on a plane. What if I wanted to have one more object that is in front of it, and when the sphere goes and hits it, I want to see, I want to take some action, right? So let's try doing that. That's kind of like the basics of, oops, hang on, how do I move it?
Well, okay, let's clone let's create another sphere over the plane, and we can basically change the inputs with something that will move the sphere forward instead of upwards.
Exactly.
We will try to hit them.
Okay, and so we have the sphere and we have the scene. So I can add a 3D thing. Hey, thanks for the follow, Gabble Wolf. That's a fun name. All right. All right, so I'm going to add another, let's say, cube. And this is the positioning of the cube thing that I get confused with, like I'm on a touchpad on my Mac. Now I'm moving it up, but what I want it to be is down there. So I don't want the Z, right? I want the Z to be 0. No, the Z actually, I moved it on the y-axis. Okay, so the Z can be 0, but the y I want it to move. Oh, the y is up. Okay. No, so we do want the
y is up, yeah.
Maybe it's okay. Maybe I'll keep the y to be, so I'll keep the sphere up, and because we are adding like up force to the sphere, so the cube can be up, and I want to see what happens when I hit it. Okay. So let me see how this looks.
The cube will fall on the sphere. The cube will fall on the sphere. Yeah, but you don't have rigid body yet.
No. So like the shadow of the cube is actually not on the sphere. Is that by design? Because like it's sitting on the same X plane. Okay.
There is a sun, and there is something like a directional light. This is the sun. You can move it actually.
Right. Okay.
It's at a slight angle. So
yeah. Okay. All right. Let's baby steps first. So the cube is sitting on 0, 5, 0, and the sphere is sitting on 0, 0, 0. So if I go back here and if I hit the spacebar, the sphere should go up and eventually hit the cube, right? Now, if I don't have rigid body, like will it just like pass through the cube? What's going to happen? Let me try.
I think that the cube will stay static. It has a collider, so they should bump just like the sphere stays on the plane when it's.
Oh, you're right. So when it bumps, it actually gives it some force down. This is nice. Oh, hey, W. Georgio. Good to see you. I remember you helping me 2 weeks back on Unity. So yes, I'm a complete noob. I'm just trying to learn here. So so both of them have gravity, and when I hit the cube, the sphere, like, is it experiencing some force downwards, like when I do that, or is it just like the gravity that's pushing it down?
I think the ball will bounce on the cube, so it will not just fall down with gravity.
Okay.
Yeah.
Okay, so
there is collisions, and there are physical materials that you can create and specify, like bounciness, for example, for the objects.
Can you tell me how? Where is the documentation for that? Where do I do bounce?
I'm not sure where you can do bounce, but if you select the sphere, you can check the rigid body. It has a property slot for
rigid body
material. And it's just in the Unity.
Yeah, I'm in Unity.
Over there.
Collision detection.
Can you expand the fields here? Okay, so in the sphere collider, it's not in the rigid body, it's my mistake. In the sphere collider, there is material.
Sphere collider. Oh, I see. What is the sphere collider? Is that an automatic component for every 3D object?
Yes, it's automatic component for the sphere. For the box, there will be a box collider. So here is how Unity works. All objects can have colliders, and Unity supports things like sphere, capsule, and box colliders.
Okay.
So you have a very complex shape. You can actually represent it with these less detailed but more efficient structures. And yeah, you can add multiple colliders to the same object. But basically, with the sphere, we have something like about that matches perfectly the sphere collider. And here in the material, you can actually create a new physics material and specify things like bounciness. I think you can click here and create a new material.
So
if you cannot do new material here, you can right click in the assets and make a new physics material.
Okay. Create new physics material 2D or 3D? Or it just says material and material 2D?
Physics material, no, not 2D, 3D.
Okay.
We are working in 3D, yeah, so that's one. That's the one.
Okay, so let me give it a name. So we're going to call it sphere material. Okay, and then this is not associated with the sphere yet, right? So do I just drag it to the sphere?
Yeah.
Okay.
I think you, I'm not sure. You can select the sphere and then drag it in the...
Okay, yeah.
The normal materials can be assigned like that those materials that change appearance, but because the sphere can have multiple colliders, you have to drag it in the property. So in the inspector, in the material, you can drag it over the properties and...
Oh, there you go. Yeah, it did it. So now in the sphere collider, in the material property is pointing to the sphere material that we just created.
Yes.
Okay. Now what?
Now you can edit the material and
so now we can choose this, and it has things like dynamic friction, static friction, bounciness. Oh, well, what is that? Just And what can I set the property to be? Whatever.
1. Basically, it's a value between 0 and 1. I think.
Oh, 0 and 1.
It controls. It controls how much of the energy will bounce back. For example, if you're running with 5 meters per second into a wall and you specify the bounciness to be 0.5, the ball will probably turn back with half the speed it had initially.
Okay.
And if you specify 1, it should bounce to infinity. I mean, if you drop the ball on a table, and it will never stop.
I see. And well, what's the friction? Like the dynamic and static friction, what are those for?
It will be hard for me to explain it with a ball, but if it was a cube, and you throw the cube on the ground, this friction basically makes the cube stop more quicker if there is more friction.
I see. Okay. All right, let's try. Let's see what that new material does. Okay, so I'm in game mode, and I'm gonna go up. Ah, look at that. Nice. Nice. I like it. Alright, so it's a little more real world. Okay, so now if I wanted to detect my sphere's collision with the cube, how do I do that? And where is the documentation for all of this? Hang on, let me
I'm not sure where is the documentation, but you can. There is a method that is
like on collision.
On collision enter.
Okay.
Yeah, on collision enter, on collision exit. These are explained in the Rigidbody.
Okay, so I actually did find the physics material that you just added. It has a whole bunch of things. Wow. Gravity, bounce threshold, sleep threshold. Okay, transforms. Oh boy. Friction types. It's a lot. Okay. And then let me see. Collision, if I just do a search. Okay, what is it? On collision?
Just a second. On collision,
on collision enter.
Oh, I can post links now. Okay, so it's on collision enter.
Oh, there you go. Yeah. So it comes down to mods. Yes. Yeah. Okay. I'm trying to see like where things are in documentation, so I'm not completely blind. So it looks like this stuff is in animations. Yeah. Okay. So manual execution order. Okay. Oh, you're actually doing it in Rigidbody.
You have to go to the Rigidbody. In the Rigidbody documentation, there is a section about messages. So you can scroll down to messages.
Messages. Oh, right here.
In the
mesh collider, compound colliders.
Yeah.
Okay, messages. What do you mean messages? What did I miss?
This. Can you check the script reference for Rigidbody? Because this is not the.
Oh, this is not the
reference. This is not like
physics.
How to guide.
Yeah.
No, it's there are articles like how to articles, and there are script references that explain properties and methods on the classes. So
okay, hang on, I'm going to pull up.
Search for script reference Rigidbody.
Yeah, I'm going to pull up our stream because I'm not looking at it, so it's getting. Oh, and I can't see your chat room because it's in the past. So, all right, because like the thing that you posted, I see it, but it's on a different computer. Okay, well, I mean, you can guide me through. All right, and I see this is like the collision detection thing is
so
it's pretty easy. Okay, so I'm on the sphere.
Yeah.
I'm on the sphere. Is there on the Rigidbody itself, right? Or no? Where do you want me to be? I see the collision detection on the Rigidbody.
Do not change this.
Okay.
Can you go a little bit up and just edit the sphere class? I think you created a sphere class. I'm not sure how it's sphere script, the one that you created.
Yep. So the sphere is just a 3D thing here, and then I've added the scripts. Under scripts, I have the sphere script. That's just the C# code you're looking at.
We can edit this C# code and add the on collision.
Okay, so this is not in. This is outside the update. This is just a event handler.
Yes. So you can create a new method and just name it on collision enter.
Is this something you have to override?
No.
okay.
That's what I mean. Messages. So Unity, most things like the example platform will give you base classes where you can override methods, will give you interfaces that you have to implement. But Unity is based on Mono, and a lot of the Unity code was written in C++ or something. And they use deflection a lot, but because it's Mono, it's not like the slow deflection of .NET. It's fine. It works okay. So a lot of the entry points for your code are just methods with names by convention. So you have to type void on collision enter.
Oh, so this is where the IntelliSense does kick in. So it's not like, I mean, there's nothing written in these methods, right? I mean, even though you see the signatures, like it's not something you're overriding, you're just like writing a separate method for it.
Yes,
okay,
absolutely. Now, some of the Unity scripts that they provide have implemented some of these methods. So if you extend an existing class, not mono behavior, but something like a text box or something similar, you will have them, but in your own class, you have to write them on your own. You can, okay, so this collision class here that you get as parameter basically will have several contact points.
Describes the collision, yeah, okay.
You can check.
Okay, so
so you can iterate the collision and
so can I like check if the collision has happened with that specific cube? Like,
yes.
Okay. So what? Let me see.
So there is a collider property on the collision. You can check if the collision.collider.
So this will actually have the game object of the thing that we collided with?
I'm not sure. I think it will be the collider of the thing that we hit.
Oh, I see. The collider of the other game object. Okay.
Yes. So we can get a reference here to the cube. Do you want to add a property?
Yep.
Yeah, you can create a collider field, public field somewhere in this class.
And it's just got a collider. Okay. Collider. Yes. And let's just say this is the cube collider.
Awesome.
Okay. And I can...
Now, if...
Oh, how do I check, like, this collider was that thing? So is there any properties that I can check what it was?
Well, basically, you have to use cube collider equals collision.collider.
Yep, that's what I did. But what I was trying to do is like, is there a way for me to check that I actually did collide with the cube and not anything else? Like, are there properties on the collider that I can see? So let me check if it's the cube collider dot. What are some properties? Attached rigidbody bounds enabled equals. Oh, it does have the game object. So like this will tell me like what game object I did collide with, right?
Yes.
And I can get all the components of that game object. And okay, so this is fairly open system here. So I can get anything from the thing that I collided. Okay.
Yes. Basically, if you have a cube with multiple colliders, you can get the game object from the collider that you hit. Like, for example, if you have a human body with several balls, one for the head, one for the leg, you can just check the game object and see, yeah, okay, I hit the...
Okay, so how about I do this? If I get... let me... So if I get the rigid body, so if I call this the cube rigid body equals the cube collider dot well, I do need to get the game object first. Okay, hang on. So I'm going to say game object, if I can type today.
Yeah, but it has to be game object, not... Yeah, okay.
Yep. So I'm getting the game object, and then I can also get the rigid body of that game object. So I can do cube dot now I know how to get the game object. It's just a get component rigid body.
Yeah, get component. Here's how it works. The game object has very few things in it. The class has a collection of components, and all of the things that we had in the inspector of the game object are actually components that are assigned to this game object.
Okay.
And the game object has a collection with components that you can iterate. So yeah, you can get by type things from the game object.
Okay, I'm going to do something funny here just to check if I can. So I'm going to take the cube's rigid body and I'm going to make it go up if I hit it. Do you think this will work?
It doesn't have a rigid body.
It doesn't have a rigid body. Yes, okay.
Yeah,
so
the cube doesn't have a rigid body at this point.
So
yeah, that...
I can, okay, remind me how I can add a rigid body here. I can go to assets, I can create, how did I add the rigid body on the sphere itself?
In the sphere or in the cube?
I have a rigid body. Like if I select the sphere here, I clearly have that rigid body. I just did not add that component to, so if I go add component, no, not a new script. On the cube, how do I add a rigid body? And
add component and type rigid body.
Okay, yeah, there you go. Okay, and so now it has the rigid body. It's using gravity, XYZ. Okay. So would it work now? So essentially, I'm saying grab the cube. If I hit the cube, get its rigid body, and then move it up as well. Let's try. Let's try. Oh, so we gave it gravity, so it just fell right away. No, why is it coming back though? This is funny. Like it's coming back because like the force we are giving it, like the gravity makes it fall down, I suppose. And whenever it does,
yeah, gravity is.
Yeah, no, go
gravity
on.
pulls it down, but every time it hits the ball, you actually add to the up force, so it also has this bounciness from the ball. So basically, it falls on the ball, it bounces, and to increase the up speed. So yeah, it's fun.
This is funny. Okay,
I think there is property in the rigid body to ignore gravity.
Yeah. Now, do you see what's happening? The sphere is rolling. Because it has this cube fell on it enough times at an angle, so it's now starting to roll. This is funny. This is so much fun.
Yeah.
So if I turned off gravity on the sphere, then it will just hang out there, right? Then I can go and hit it. Okay, here we go.
Yeah, they use gravity, yeah.
So there we go.
You should be able to hit it.
See, now it just went off. And hopefully it'll come. No, it won't ever come down, right? Because it doesn't have gravity.
Yeah.
Oh,
so now you can enable the gravity on the rigid body once you hit it. Basically, once you hit the rigid body, you can set the use gravity to train this share code.
Oh, hang on. 1 second. I hit the wrong button here. So
kind of.
So this is interesting. So excuse me. So what I did here was. This collision detection was on the sphere itself, and when the sphere hit the cube, we added this force. But this was done on the cube. Okay, yes. And then how do I enable gravity on this? Is there a property?
Yeah.
Cube rigid body dot use gravity. Okay.
Use gravity. So yeah.
So now it'll just come down and then we'll hit it again. Okay, this is funny. This will be funny. Ah, come on. There we go. Okay, so nothing changes until I go and hit it. And then the sphere will fall and then the cube will fall on top of it. There. And now we'll let the sphere fall. And the cube falls on it and just bounces off. Okay. This is fun. This is really fun. So we can give it like a smaller energy, like smaller force, and then it won't bounce as much. There you go. So how does does this cube have bounce at this point? It doesn't, right? It's just using the force that I'm giving it.
I'm not sure, to be honest. There was a way to resolve the bounciness of a collision between two objects, and since the sphere has a physics material that has bounciness of 1, and the cube doesn't have a material, I think it will try to figure out something in between. But you can assign material to the cube as well and control the bounces.
Okay, but this is a lot of fun, and obviously we can give it velocity, so it can go like X, Y, and Z with that mass, right? And it can go hit other objects. This is a lot of fun. This is a whole new world coming from just regular C# development. This is a whole new world. What about like particle, like collision, and when things like have to be like damaged? Like, is there anything built in?
Yes, there is particle systems. I think you can right click on the cube and add the particle system.
Oh, really?
And you can basically disable it and enable the particle system on a collision and see what happens.
Is that on the rigid body, or it's just something new?
No, it's something new that we have to create in the cube. I think you can right-click the cube in the sample scene hierarchy.
Whoa, what is this? Particle effect. What am I even looking at? What is this?
That's the particle system. You have to define all the properties of the particles, like you can add gravity to them so they can fall down and don't just fly to the side. You can disable the particle component, I think, and you can enable it when the two objects collide. Okay.
Well, this seems like something I have to play around and make sure, like, so like, what does it do? Like, if I just like play it, what would the particle system actually do? So, what are these things flying off the sphere?
So this is how particle systems work. There is an object that is generating a lot of lightweight. Smaller objects, like they're not full game objects in that sense, but you'll generate a lot of them. So if you want to simulate a flame, for example, or if you want to simulate something like a crash with a lot of tiny objects flying around, you use these particle systems. They have a way to render things with a single polygon, for example, instead of geometry like the cube or the sphere. And the computations for these objects have to be very efficient because they'll be generated a lot of small details like them. So you have a mechanism to add certain forces or colliders that affect all of the particles, but they're very basic. I mean, you cannot make them hit like the cube and trigger something called the cube.
Sure. Okay.
they're kind of yeah.
Yeah, there definitely seems like a lot to read up and do right with the particles the moment we add something to it. So that sounds like a whole other conversation, and maybe we can tackle it next week. So folks in the chat room, or if you're watching this later on, so far what we have done in the last like 2 to 3 weeks is essentially just me completely coming in blind, not knowing anything about Unity, but I am having a lot of fun. This is completely something else. Like when you bring in physics, when you have knowledge of gravity and collisions, really, I mean, the world is an open field for you to paint however you want. So this is a lot of fun for me, but as much as it is fun for me, I realize like this is very basic stuff if you're especially doing Unity. So something that Pana and me were thinking of is to let the expert actually show you or kind of walk me through how to build something real. So maybe we'll do something like that starting next week. We do have a conference that's coming up, and we were thinking of building a little world so things can be virtual on VR. So we'll talk more and we'll see how we go about doing that. So I mean, I can keep on learning the basics of Unity forever, but I'm guessing this is not very useful for somebody. I mean, it could be useful if you're just learning Unity like me, but you'll soon graduate to something more real, and I think that's where we want Pana to actually show me something real. So we'll talk more and see how we go about doing that. But I think that's about it. We have run an hour. So Pana, I mean, am I on the right track? I'm learning about the physics, and there is a lot to digest here. But this is an incredible world. This is incredible, the way things interact. This is so much fun.
Yeah, absolutely. You're on the right track. Basically, most of the games, like if you take Angry Birds, for example, you just change the balls and the cubes with the 3D models, and it's the same thing. Yeah.
Yeah, I mean, it's funny you mentioned Angry Birds. Like my son is 4 and he is getting into Angry Birds because they actually just hit like 10 years of running Angry Birds in different formats. So I mean, the games have also come a long way. So yeah, this is a lot of fun, and I am definitely learning a lot. So come back and join us next Tuesday. Maybe we keep moving forward with this, where I can learn a little bit more about like the VR aspect of this. Or we have like Pana drive and start building something real. So for all of that, come and join us here on Code It Live. We appreciate you. We love you. So come and join us whenever your time permits. Pana, I want to thank you again for taking the time to come and teach me. This is a lot of fun for me.
Thank you.
All right, folks, that's it from us then. Like I said, we appreciate all of you, and we shall see you next time. Okay? Bye-bye for now.
Bye-bye.